Hello champions, welcome to the next lecture on the ordinary differential equations. Today I will upload the next video related to your request that is named as the 20 plus examples on the Lipschitz condition. In this lecture I will explain you the simplest way how you can solve the Lipschitz conditions which are very useful for the CSR net, GATE and the IIT JAM examinations students. Myself Dr. Harish, you can follow and subscribe my YouTube channel. What we have discussed so far, we have learned the concept of the Lipschitz conditions in which we have discussed under what case you will get the existence and the uniqueness solutions. Fine. अगर अभी तक आपने ये लेक्चर नहीं सुना है then you must find my playlist ordinary differential equations and you can see the lecture of the Lipschitz condition. बड़ा ही डिटेल में ये लेक्चर बताया मैंने, टाइप्स ऑफ द लिप्शिट्ज़ कंडीशन भी बताया है, एग्जांपल के साथ भी बताया है और एक सिंपल ट्रिक बताई है जिससे आप चेक कर सकते हो when the solution will be existence and uniqueness. Now in this lecture I will explain you the more than 20 plus examples which will helpful for you to understand the concept of the Lipschitz conditions. Fine. And after this video or at the end of this video I will give the 7 examples as an exercise for you. Fine. 7 examples as an exercise for you. You can solve them by own and let me know your answer in the comment box so that I can understand कि आपको ये lecture अच्छे से समझ में आया है. If I quickly recall you the last lectures, we have discussed the two different form of the Lipschitz conditions that is defined in equation number 1 and equation number 2. Equation number 1 is known as the strong form of the Lipschitz conditions, while the equation number 2 is known as the weak form of the Lipschitz conditions. For more details about the features of the strong form, for more details about the weak features of the weak form of the Lipschitz conditions, you must watch about the lecture of the Lipschitz condition which is the last lecture. Fine. वो last lecture बच्चों आपको इतना कुछ सिखा जाएगा Lipschitz condition के बारे में, something new to you as well. Now अब क्वेश्चन ये उठता है कि एग्जामिनेशन में कैसे पता लगे कि कौन से कंडीशन से आपको Lipschitz चेक करना है. First of all, I will tell you the simple tip. Whenever you will see any of the function f of xy for the initial value problem, y dash is f of x comma y. Make sure students the coefficient of the y dash must be 1. If the f of x comma y involve mod of y terms, fine. कभी भी आपके पास f of xy में modulus of y की term present हो, then you must apply the equation number 1 to check about the Lipschitz conditions. While for all the other cases कौन से होंगे जिसमें mod of y नहीं लिखा होगा, then you always apply the del f by del y is my k. Make sure k must be the constant. Fine. Constant means you can say that is independent of x, y1, y2. फाइन. इंडिपेंडेंट ऑफ द एक्स एंड वाई. क्लियर. सबसे पहले तो यही नहीं समझ में आता कई बार कि दोनों में से डेफिनेशन कब लगानी है कब नहीं. इज इट क्लियर. कभी भी मोड ऑफ वाई की टर्म प्रेजेंट आ जाए देन ऑलवेज अप्लाई द फर्स्ट केस. अगर मोड ऑफ वाई नहीं लिखा देन ऑलवेज अप्लाई द सेकंड डेफिनेशन. नाउ second way is once you will or the sufficient test for the Lipschitz condition is if you prove that the del f upon del y is a continuous and bounded. How you can prove the bounded? That is the del mod of del by del y is less than equal to finite number. Make sure students these are continuous and bounded of the del f by del y. Fine. f के बारे में नहीं कह रहा है, del f upon del y. एक और रिमार्क अभी मैं दे रहा हूं. और अगर if del f upon del y is only continuous not as bounded, then we call as a weak Lipschitz condition. Fine. इसका क्या मतलब है? Whenever you have the initial value problem which are defined as the equation number 1, इसका solution exist करेगा. Fine. और solution unique होगा. इसकी क्या गारंटी है? इसकी गारंटी कौन देता है आपको? Lipschitz condition. You can find the del f upon del y. Again make sure the coefficient of the y dash must be 1. Fine. अगर तो f आपका del f upon del y continuous है then you can say the solution existence एग्जिस्टेंस ऑफ द सॉल्यूशन गारंटेड। फाइन। और अगर ये डेल एफ अपॉन डेल वाई बाउंडेड नहीं है, इट्स नॉट बाउंडेड, देन देर इज नो गारंटी ऑफ द यूनिकनेस। देर इज नो गारंटी ऑफ द यूनिकनेस। और अगर ये डेल एफ अपॉन डेल वाई बाउंडेड है, देन यस द गारंटी ऑफ द यूनिकनेस एज वेल। फाइन। Once it's a uniqueness fail, then you have to apply the Picard's method to check whether there is existence of the unique solution, infinite many solution, or the no solution. How you can apply the Picard's method? You can watch my previous lecture, Picard's method of the initial value problem. Clear students? एक और इंपॉर्टेंट बात मैं पूरे लेक्चर में यूज करूंगा, कंडीशन इज एफ ऑफ एक्स कॉमा वाई, फाइन, वेयर y dash is defined as dy over dx. In this case, x is my independent variable, fine, and y is my dependent variable, fine. Then in order to check about the Lipschitz condition, we always find del f upon del y. Y is my dependent variable. लेकिन कई बुक्स इसको इस तरह से भी लिख देती हैं, एक्स डैश इज एफ ऑफ टी कोमा एक्स, दैट मीन्स ये आपका क्या होगा, डी एक्स ओवर डी टी. तो कैन यू फाइंड द इंडिपेंडेंट वेरिएबल? टी इज माई इंडिपेंडेंट वेरिएबल, फाइन, एंड एक्स इज माई डिपेंडेंट वेरिएबल. तो इस केस में आपका लिप्सिट्ज़ कंडीशन क्या हो जाएगा, डेल एफ अपॉन डेल एक्स, फाइन. तो कहने का मतलब जो डिपेंडेंट वेरिएबल होगा, जिस भी नोटेशन को आप यूज करने जा रहे हो, दैट इज विद रिस्पेक्ट टू फंक्शन. क्लियर? चलिए, द लास्ट पॉइंट इज व्हेनेवर यू नीड टू चेक अबाउट द लिप्सिट्ज़ कंडीशन, यू ऑलवेज नीड टू चेक अबाउट द बाउंडेडनेस, एब्सोल्यूट वैल्यू और द मॉडुलस ऑफ द डेल एफ अपॉन डेल वाई इंस्टेड ऑफ ओनली डेल एफ बाय डेल वाई. So let's start with the 20 plus examples. Fine. In this lecture, you must watch the video till the end. Definitely you will learn many new concepts. चलिए, it's the first example. मैं पहले example को आपको दोनों मेथड से solve करके दिखाऊंगा. Fine. First method कौन सा आपका? When I use x comma y2 minus f of x comma y1, which is less than equal to k times y2 minus y1. And the second method is I will use the second method by computing the del f upon del y. Fine. जब भी आपको लिप्सिट्ज़ कंडीशन डिफाइन करनी हो, तो आपका स्टेप नंबर 1 हमेशा ही क्या होगा, यू हैव टू डिफाइन रेक्टेंगल. अगर तो रेक्टेंगल गिवन है, दैट्स फाइन. अगर गिवन नहीं है, देन हाउ यू कैन डिफाइन द रेक्टेंगल? रेक्टेंगल इज ऑलवेज डिफाइंड एज x minus x naught is less than equal to a, y minus y naught is less than equal to b, where a and b both are my positive, and x naught and y naught क्या होगा? If you have the initial value problem such that y of x naught is equal to y naught, तो ये आपका जो x naught है, that you can find from here. This y naught you can find from the given conditions. Fine. तो यहाँ पे तो आपको rectangle is already given to you. Fine. अगर नहीं गिवन होगी, then you have to define the rectangle in such a manner. Clear? चलिए, first method, we can take any 2 point x comma y1 and x comma y2 from the rectangle. So let's substitute the value. What is the value of the f of x comma y2? X square plus y2 square minus x square minus y1 square. X square and x square cancel. I can write as a plus b, a minus b. Fine. y2 minus y1. Is it okay? Now we all knows what is how you can write as a y2 plus y1, which is less than equal to mod of y2 plus mod of y1, and the value of the y on the rectangle is less than equal to b. I can write this number is b plus b, which is my 2b. I can write this number is less than equal to twice b y2 minus y1. Fine. Now you can see by the definitions, f satisfied my Lipschitz condition. Fine. F satisfied my Lipschitz condition, and this 2b is my Lipschitz constant. Fine. और Lipschitz condition satisfied का मतलब क्या है? whenever you have the differential equation, fine, over the rectangle, then it will provide you the uniqueness solution. Fine. Second method, we can start with the del f upon del y is a 2y. I can written as a 2 into y, and what is the value of the y is less than equal to b, and you can see this number is my constant, and once this is number is constant, yes, the Lipschitz condition satisfied, and Lipschitz constant is 2b. Look at the next one. Consider the function f. तो देखिए यहाँ पे mod of y तो नहीं लिखा हुआ. Fine. I can start with the del f upon del y. क्या rectangle यहाँ पे define है? नहीं है. तो we will firstly define the rectangle. Initial point given है आपके पास x naught and y naught. Is the point is given to you? No. The point is my on the R2. So आपकी rectangle क्या होगी? Complete xy plane. That means your first quadrant, second quadrant, third and the fourth is my complete xy plane. So that means your rectangle will be collection of all those pairs x comma y such that mod of x is less than infinity, mod of y is less than. ये तो second quadrant बनेगा ना. Now let's start with the del f upon del y. Can you find the derivative? This number is a 1 and it is a bounded, which is a constant number. So yes, f satisfied my Lipschitz conditions. But make sure students, is your f is a continuous? Is your f is continuous on the R2? Definitely not, because the greatest integer is not continuous on the integral values of the x. Look at this one. Now you can see it's a modulus value. So I can start with the first definition. यहीं से start करना होगा. पहले rectangle define करोगे. Define the rectangle. Collection of all those elements of the x comma y such that x minus x naught. X naught is my 0, which is less than equal to a. Y minus y naught is less than b, where a and b are my positive numbers. If you draw it on the graphically, what is the meaning? Mod of x less than a, that number is my x is equal to a, x is equal to minus a. This line is my y is equal to b, and this line is my y is equal to minus b. So can you find the proper rectangle? Rectangle is my this shaded portion. Fine. This is my rectangle S. Now we will check whether the function f which are defined in this shaded portion will satisfy my Lipschitz condition or not. क्योंकि यहाँ पे modulus लिखा हुआ है, so I can start with the definition of modulus. I can substitute the value y2 minus y1 and the numerator becomes root of mod y2 minus y1. Fine. So for the sake of simplicity, I can choose the y1 is my 0. Fine. अगर मैंने y1 0 ले लिया तो y2 तो 0 नहीं ले सकता ना, तो y2 I can choose any positive number. So the right hand side becomes, तो mod of y2 positive हो जाएगा because y2 is my positive, this number is my y2. तो ये कितना हो गया आपका 1 over y2. Fine. And you can see that number will goes to the infinity as y2 will goes to the 0. Exactly 0 ना हो क्या. Fine. क्लियर. अब क्या आपका y2 इस डोमेन में लाई करता है? यस, बिकॉज आप देखो आपने रिटेंगल क्या बनाई थी आपने, यहां देखो 0 is lies in the rectangle. Fine. Y is equal to 0 is the part of the rectangle. Fine. So whenever y approaches to the 0, that means either from the upside or from the below side, the function will not satisfy my Lipschitz condition. Hence, f is not satisfied my Lipschitz condition on this particular rectangle S. अगर ये Lipschitz condition नहीं satisfied हो रहा, then whatever the problem of the initial valued y of 0 is equal to 0, uniqueness is not guaranteed. Fine. यूनिकनेस की कोई गारंटी नहीं है. फाइन. यूनिक हो भी सकता है, नहीं भी हो सकता. उसके लिए आपको क्या करना होगा? यू हैव टू अप्लाई द पिकार्ड्स मेथड टू चेक वेदर द सॉल्यूशन इज यूनिक और नॉट. और मैं फिर से बता रहा हूं, पिकार्ड्स मेथड आपके पास ये लेक्चर प्रीवियसली पढ़ा हुआ है आपके पास. फाइन. अगर आप बच्चों चाहते हो कि मैं इससे इससे नेक्स्ट लेक्चर एग्जिस्टेंस एंड यूनिकनेस थ्योरम का सेपरेट अपलोड करूं 25 और 30 प्लस एग्जांपल के साथ, यू कैन टेल मी इन द कमेंट बॉक्स, मैं एक सेपरेट लेक्चर भी यूनिकनेस एंड एग्जिस्टेंस सॉल्यूशन का अलग से अपलोड कर दूंगा आपके लिए. चलिए, look at the next one. Again, the rectangle is already defined to you. Find, check whether the function is satisfied or not. कहीं पे mod of y तो नहीं लिखा हुआ. Fine, I can start with the del f upon del y. Fine. So can you define the derivative? Clearly say it's a, okay, I can do for you. What is the del f upon del y? Which is 2xy. Fine. 2xy I can written as a twice mod of x into mod of y. What is the mod of x? This number is my less than equal to 1. Mod of y is also less than equal to 1. So which is a bounded, which is a finite number. So hence the Lipschitz condition satisfied and 2 is my Lipschitz constant. On the other hand, mod of x is less than equal to 1. So let's start with the again del f upon del y, which is my 2 times mod of x mod of y. Clearly say mod of x is less than equal to 1. So that number is my 2 of mod y. Fine, because y का bound तो given नहीं है. Will it be a constant? No, it is not a constant, क्योंकि हर एक y की अलग अलग वैल्यू के ऊपर आपको एक अलग अलग आंसर मिलेगा. Fine, so that means Lipschitz condition not satisfied, or you can say this number will goes to the infinity as y goes to the infinity. क्या y infinity part होगा इसका? You can see this is the line corresponding to x is equal to 1. This is a line corresponding to x is equal to minus 1. So can you draw the shaded one? X lies between minus 1 to plus 1 and y goes to the infinity. So basically you are talking about the strip. Fine. This is my strip, and yes, y will goes to the infinity. Y will goes to the minus infinity. Therefore, the Lipschitz condition is not satisfied because del f upon del y is my unbounded. Look at the next one. Check whether the Lipschitz condition satisfied or not. Again, modulus is not given. So we can start with the, again the rectangle is already defined to you. Fine. Let's start with the mod del f by del y. It will be 2 over 3 y raised to power 1 over 3. 2 by 3 is outside. That number is 1 over y raised to power 1 over 3. So if you draw the rectangle, it's a minus 1 plus 1, y is equal to 1, y is equal to minus 1. Your rectangle is my this one. Fine. This is x is equal to 1, y is equal to minus 1, y is equal to 1, x is minus 1. This number is my 0, and yes, you can see whenever y approaches to the 0, that number will go to the infinity. Fine. And also you can say y is equal to 0 is the part of the rectangle. Fine. So therefore del f upon del y is my unbounded function. Hence the function not satisfied my Lipschitz condition. Look at the next one. Again modulus नहीं लिखा हुआ. We can start with the del f upon del y. Find the derivative x cos of y plus 1 into cos of x. I can use the inequality. Mod of a plus b is less than equal to mod of a plus mod of b. Fine. I can use this number is mod of x is separate is a cos of y plus cos of x. And we all know cos x and cos y are my bounded functions. And what is the value of the x? X is my less than equal to a. Fine. This number is my 1 plus 1, which is a plus 1. And clearly say this number is my finite, or you can say it's a independent of the x and y. That's a constant. Yes, f satisfied my Lipschitz condition. And what is my constant? Constant is a plus 1 is the right answer. फाइन. मैं बच्चों बार बार बता रहा हूं लिप्स्टिच कंडीशन सेटिस्फाइड का मतलब क्या है. जो भी इनिशियल वैल्यू प्रॉब्लम इसके ऊपर बनी, दिस इज माय एफ ऑफ एक्स कॉमा वाई ऑन द रेक्टेंगल आर. फाइन. दैट विल गिव यू द यूनिक सॉल्यूशन, द गारंटी ऑफ द यूनिक सॉल्यूशन एंड द एग्जिस्टेंस ऑफ द यूनिक सॉल्यूशन. मैं फिर कह रहा हूं, अगर आप चाहते हो कि मैं एग्जिस्टेंस एंड यूनिकनेस नेक्स्ट लेक्चर I will upload on the 30 plus questions. Let me know in the comment box. I will upload you for you. Fine. उम्मीद करता हूँ वीडियो को लाइक और चैनल को सब्सक्राइब जरूर कर दोगे अभी तक. Now you can see it's a modulus of y. So we will apply the first definition of the Lipschitz conditions. Now if you read the statement, consider the function f, proof that f satisfied my Lipschitz conditions. However, although del f upon del y does not exist. फाइन, अगर आप सेकेंड डेफिनेशन लगा रहे हो, फाइन, और एक तरफ ये कह रहा है कि डेल एफ अपॉन डेल वाई डज नॉट एग्जिस्ट, फाइन, और एक तरफ कह रहा है कि ये आपके पास लिप्स्टिस कंडीशन सेटिस्फाइड हो गई, हाउ इट इज पॉसिबल, फाइन। तो इसका रिमार्क भी मैं आपको इसी में लेक्चर में दे रहा हूं। सबसे पहले चेक करते हैं वेदर दिस पार्शियल डेरिवेटिव ऑफ एफ विद रिस्पेक्ट टू वाई एग्जिस्टेंस और नॉट। व्हाट इज द डेफिनेशन ऑफ द डेल एफ अपॉन डेल वाई, व्हिच इज द लिमिट y approaches 0 f of x comma y minus x comma 0 divided by y। x को फिक्स रखना पड़ेगा ना आपके पास, फाइन, आई कैन सब्सटीट्यूट दी वैल्यूज। व्हाट इज द लिमिट y approaches 0, what is the value of the f of xy is x cube mod of y, and what is when y is equal to 0 f is my 0, fine, and take an x cube is outside, fine, then the expression becomes limit y approaches 0 mod y divided by y. What is the limit of this portion? Clearly say this is either the plus 1 or minus 1. That means limit is not unique, and once the limit is not unique, that means limit does not exist, and once the limit does not exist, that means del f upon del y does not exist at the point x comma 0, fine. Now because the modulus value is written, so we can start with the definitions, first definitions. So let's start with this case, y2 minus y1, fine, numerator becomes x cube, y2 minus x cube y1. I can take an x cube as a common, modulus of x cube is common, then it is a y2 minus y1 divided by y2 minus y1. What is the value of the mod of x? Mod x is less than equal to 2 because it's x cube. I can written this number is less than 8. This quantity I can also be written as y2 minus y1 divided by y2 minus y1. Why? Because of the inequality, this factor. Now clearly say which is my constant number, fine, or you can say it's a finite number. Yes, the Lipschitz condition satisfied with the Lipschitz constant 8, fine. अब क्वेश्चन ये है कि पार्शियल डेरिवेटिव इज डज नॉट एग्जिस्ट व्हाइल द लिप्स्टिस कंडीशन सेटिस्फाइड, व्हाई इट हैपेंस सो, बिकॉज मैंने पहले ही आपको क्या रिमार्क बताया था, whenever you will need to check about the Lipschitz condition, we always need to check about the modulus of the del f upon del y instead of only del f upon del y. Look at the next one. Again the rectangle is given to you, you have to check whether the Lipschitz condition satisfied or not. Again modulus तो लिखा नहीं हुआ, we can start with the del f upon del y. Rectangle is already given to you, fine. If you find the derivative you will get this case. Now what will happen, it goes to the infinity as y goes to the 0. So whether the 0 is the part of this, yes, fine, 0 है ना आपके पास rectangle में, and y is equal to 0 is the part of the rectangle. इसका क्या मतलब हो गया, that means del f upon del y is unbounded function, fine, and once this case is unbounded, that means f is not satisfying the Lipschitz condition, fine, f is not satisfying my Lipschitz condition on the particular rectangle S. अगर यहाँ पे डोमेन को 1 is less than y is less than 7 कर दिया जाए फॉर एग्जाम्पल, फाइन, तो क्या ये कभी इंफिनिटी जाएगा, देन इट नेवर गोस टू द इंफिनिटी बिकॉज y is 0 तो इसका पार्ट ही नहीं है, फाइन, एंड इन दैट केस यस द Lipschitz condition will be satisfied. Okay, look at this another one. Again rectangle is given to you, fine, x is equal to 1, x is equal to minus 1, y is infinity, तो आपके पास ये स्ट्रिप बन गई पूरी. Fine. Basically, this is not a rectangle. This is my strip. Fine. Again, कहीं मॉडुलस तो लिखा नहीं हुआ. So let's start with the del f upon del y. Fine. फंक्शन आपका कंटिन्यूस होना चाहिए, वो मैंने पहले ही आपको इस प्रीवियस लेक्चर में बता रखा है. चलिए, इसको कैसे, इसका डेरिवेटिव करा आपने, चलो मैं आपको करके दिखा दे रहा हूं. विद रिस्पेक्ट टू y करना है आपको. सो इट्स x स्क्वायर, दैट इज माय 2 cos of y. Cos will be my minus sin y. Fine. Plus 1 into sin square x. क्लियर. सो इसको मैं क्या लिख सकता हूं, इट्स साइन ऑफ 2x, इट्स नेगेटिव x स्क्वायर साइन ऑफ 2y प्लस साइन स्क्वायर x. इसको मैं फिर से लेस देन इक्वल टू x स्क्वायर साइन ऑफ 2y प्लस साइन स्क्वायर x लिख सकता हूं. अगेन आई कैन राइट दिस नंबर इज x स्क्वायर, साइन की मैक्सिमम वैल्यू 1 हो जाएगी, प्लस साइन स्क्वायर इज ऑल्सो 1. व्हाट इज द x वैल्यू? Mod of x is less than 1. 1 square will be 1. 1 plus 1 is my 2, which is a finite number. So yes, the Lipschitz condition will be satisfied and the Lipschitz constant is my 2 is the right answer. Look at the another one. Now you can see, first of all, we can define rectangle. Fine. So rectangle is collection of all those elements of the x and y such that x minus x naught is less than equal to a. The point x naught is given, the point y naught is given. So x minus x naught is my 0, y naught is also 0. So y minus y naught is my 0, which is less than equal to b, where a and b both are my positive numbers. Fine. So we can define the rectangle. अगर आप इसको ग्राफिकली देखना चाहते हो, what is the rectangle is mod of x is equal to a, because a is my positive, fine, and b is my positive, y is equal to b, y is equal to minus b. So your answer is, this is my complete rectangle. Fine. Clear. Now we can start with the derivative. Because modulus तो लिखा नहीं हुआ, we can start with the del f upon del y. So it is a 3 into 4 over 3 y raised to power 1 over 3. So that is a 4 is outside, y raised to power 1 over 3. Can it goes to the infinity? No, because the infinity कब जाएगा? It goes to infinity whenever y is goes to the infinity. But infinity is not the part of the rectangle. तो इसका मतलब ये कभी भी infinity नहीं जाएगा. Fine. And what is the value of the y? You can see mod of y is less than equal to b. So I can write this number is less than equal to 4 times b raised to power 1 over 3, which is my finite number. Once it's a finite number, yes, you can say the Lipschitz condition satisfied and the Lipschitz constant is 4b raised to power 1 by 3. Fine. बच्चों इस लेक्चर को ध्यान से सुनिए. टेलर सीरीज, पिकार्ड्स, लिप्सिट्ज़ कंडीशंस. Fine. That is a very beneficial for all of you. Okay, look at another one. Check whether the function f defined on the rectangle is given to you, where a and b are the continuous function on the mod of x is less than x. Satisfy the Lipschitz condition or not. Fine. चलिए del f upon del y कर देते हैं. Start. Fine. अगर आप rectangle बनाना चाहते हो, इसकी rectangle क्या बनेगी? x is equal to 1, x is equal to minus 1. Fine. Y is equal to 2 and y is equal to minus 2. So your rectangle will be, this is my complete rectangle. Clear? Now, so let's start with this case. Partial derivative with respect to y. So twice ax into y plus b of x. I can return this number is less than equal to twice of ax. Fine. Twice of ax into y plus mod of bx. Fine. I can return again, this is less than equal to a of x mod of y plus b times mod of x. What is the value of the y is 2. So this number will be less than of the 2. I can written as a 4 times a of x plus b of x. यहां तक तो समझ में आ गया. फाइन. अब क्वेश्चन ये है कि इसकी वैल्यू लेस देन इक्वल टू कितनी होगी. फाइन. तो can you say ax is my ax and bx are my bounded. How you can prove that they are my bounded. अगर तो ये bounded नहीं हुए, if they are not bounded, then in that case, if a and b are not bounded, what will happen? That means a will go to the infinity, b will go to the infinity. In that case, del f upon del y will go to the infinity. But can you prove that it's a bounded or unbounded? Read the statement very carefully. What is given to you? A and b are continuous functions. Find on mod of x is less than equal to 1. And you can see about this domain. The domain is my closed domain. This is my closed domain, and the continuous function on the closed interval. What does it implies? That implies bounded. Fine. Any continuous function on the closed interval is a bounded function. इसका मतलब a and b are my bounded functions. Once a and b are my bounded functions. Fine. इसका मतलब क्या होगा? a of x की कोई ना कोई एक maximum value मिलेगी. I call as a m of a, and b of x की कोई ना कोई एक maximum value मिलेगी. I call as the m of b. I can substitute both the values in this equation. That is my 4 times ma plus mb, where ma and mb are the maximum values or called as the bounds of this. Now clearly say this is my finite number. Yes, the Lipschitz condition will be satisfied. Look at another one. Check whether the function f of xy is satisfied Lipschitz condition or not. First of all, if you define the rectangle, x is equal to 0, x is equal to a, mod of y is less than infinity. तो आपकी rectangle क्या बन गई? Your rectangle will be this case. So basically this is my strip. Fine. This is my strip. Clear? So let's start with the del f upon del y, because modulus तो लिखा नहीं हुआ, तो y के साथ डेरिवेटिव करेंगे. x cube is here, e raised to power minus xy square into minus 2xy. So that will be minus of 2 का modulus 2 हो गया. That will be x raised to power 4 e raised to power minus xy square into y. Because x की वैल्यू क्या है आपकी 0 to a and a is my positive, that means x is always a positive number. तो यहाँ modulus of the x4 को मैं simple x4 लिख देता हूँ. Y can be negative. Fine. I can written as a mod of y, e, and e is always a positive number. Fine. So that is my partial derivative. Clear? Now, how you can prove that this number is less than or equal to something? Fine. X we have known. The value of the x will be less than equal to a. I can write this number is less than equal to twice a raised to power 4 y e raised to power minus x y square. Fine. अब ये number less than कब मिलेगा? If you are able to find the maximum value of this function. Fine. How you can find the maximum value? I call this function is my g of y. Fine. And my target is to find the maximum value of this part. Fine. If I choose g of y is my here. And how you can find the maximum? You can start with the first derivative to be the 0. लेकिन यहाँ modulus of y लिखा है और यहाँ simple y. Then you have the two cases, either y positive or y negative. Fine. But मैं आपको आसान तरीका बता रहा हूँ. Instead of writing as a positive and negative, can I write this number is mod of y e raised to power minus x? You can see that is my y square, which is always a positive number. So I can write this number is mod of y square. Fine. So my condition will be, we can find the derivative of the y is 0, where the derivative we can taken with respect to mod of y. Fine, because यहाँ हर जगह पे mod of y ही लिखा हुआ है. Fine. So can you find the derivative with respect to mod y? So product rule is 1 into e raised to power x mod y square plus e raised to power minus x mod y square into minus 2x into mod y is 0. E raised to power can never be 0, so that number is 1 minus 2x mod y square is 0. Can you find the value of the mod of y? Mod y will be 1 over under root 2x. Fine. Now for the maximum case, so that means this number will be less than or equal to 1 over root. I can substitute the value of the y in g of y. So your g of y will be less than equal to 1 over root 2x e raised to power minus e raised to power y square. Y square will be 1 over 2x. X and x will be cancelled out. I can substitute the value of the gy at this is my gy. Fine. Now gy is my less than, so it is less than equal to 2 times x raised to power 4. Fine. तो मैं इसको क्या लिख सकता हूं 2 divided by root 2 separate x raised to power 4 divided by root x 4 minus 1 over 2. So 8 minus 1. 8 minus 1 is 7 by 2. Fine. And e raised to power minus half. Clear? That number will be my root 2. This e I can written as a denominator. X will be my less than a. So a raised to power 7 over 2. Fine. Clear? So I can return this number is again root 2 divided by e a raised to power 7 over 2. Moreover, you can also see e 2 over e is always less than 1. मैं थोड़ा सा और आगे कर देता हूं which is less than of a raised to power 7 over 2. Why? Because root of 2 by e is always less than of 1. So that is my proper bound of the function. Now since this number is my constant, hence the Lipschitz condition is satisfied and the right answer of the bound is a 2 raised to power 7, or you can write at the bound is root 2, or you can write as a root 2 over e a raised to power 7 over. चाहे तो ये लिखिए bound और चाहे आप a की power 7 by 2. Fine. So this is a simple way you can solve all those 20 plus example in this video. Now it's your turn. You can solve your answers. Question number 1, 2, 3 and the next 4 questions. You can solve this and let me know whether the first part will yes or no, whether satisfied the Lipschitz condition. Second part, whether satisfied Lipschitz condition or not, and so on. You can solve it and let me know your answer in the comment box so that I can understand it, whether you are able to understand this lecture deeply or not. I will upload the next lecture on the existence and uniqueness solution. Till then, you can share this video with your friends, like and comment on it. Best of luck, students. Happy learning.